Welcome to lesson 2.8c. Today we're going to talk about polyatomic ions. Polyatomic ions are ions that behave as a group, and with polyatomic ions, basically I encourage you to make flashcards and memorize these names and formulas and charges, because there's really no other way to do it. You just have to memorize them. Some of your polyatomic ions are what we call oxyanions, and that just means that they have an atom of a given element with some oxygens as well. When these rules in terms of names, that's part of the memorization process, this one and this one as well. But here are your polyatomic ions, and there are only two positive listed on this table. There's mercury 1 and then ammonium. Those are your positive polyatomic ions, and there's lots and lots of oxoanions and just a few anions that don't have oxygen in them. What I encourage you to do is, if you can memorize the 8s, so like for instance this is nitrate, and you know it has 3 oxygens and a -1 charge, then nitrite is going to have the same charge but it's down 1 oxygen. If you can memorize sulfate, then you know sulfite is same charge but down 1 oxygen. Over here, if you can remember chlorate is down 1 oxygen, same charge. And then on chlorites, or the chlors, we also have hypo and per. And so just I encourage you, like I said before, to make flashcards and memorize those polyatomic ions, because you're going to see them in on quizzes and on exams, and you're going to have to know the names of those. So when you use polyatomic ions, or when polyatomic ions are in a formula, then you just simply use the name. You don't change the name at all. So for example, this first one, this is sodium, this is sulfate, so this was just simply going to be sodium sulfate. So same type of rules as before, where if you have a cation that only has one possible charge, no Roman numeral. If the cation has more than one charge, then you have to indicate what the charge is with the Roman numeral. So the second example, that manganese compound, manganese 2 hydroxide, because hydroxide has a -1 charge as a whole. This has a -1 charge. There are 2 of them. Total of -2 means this half of the compound needs to be a +2. Now, in terms of writing polyatomic ions, it's basically the same kind of rule, only you just remember that the polyatomic behaves as a unit. So when you write sodium hydrogen carbonate, you have sodium, and that's a +1, and then you have hydrogen carbonate, hydrogen carbonate, and that's a -1. That's a -1. That's okay, and so that balance each other out, so it's just simply sodium hydrogen carbonate. Now on the other one, the selenate polyatomic ion is a -2 charge, so that means that you need 2 sodiums to balance out that -2 charge on that selenate. Now, let's do another quick example. Let's say I want you to write the formula for aluminum hydroxide. Okay, sorry about that. Again, I'm writing with a mouse, so it's kind of hard to write. So aluminum hydroxide, aluminum is Al, and it has a +3 charge. Hydroxide is a polyatomic, and so it is OH, and as a whole it has a -1 charge. So if I crisscross, I end up with 1 aluminum, but I end up with 3 hydroxides. So in that case, since I have multiple polyatomic ions, that means I need to put parentheses around that polyatomic ion before I add that subscript, because I have 3 of those units. So parentheses are used when you have multiple polyatomic ions. Okay. All right, so please look in your books, check the homework, the sapling homework, and practice this concept. And the next time we are going to talk about type 3 compounds, which are your covalent compounds.